Good morning, everybody. Welcome to the 16th CRE lecture by Dr. Sriram. Ram is a contemporary when I did my PhD at CMU, and we have known each other for a very long time. And he is currently the Chief of Software and Systems Division at Information Technology Laboratory at the National Institute of Standards and Technology. Before that, he was the leader of the Design and Process Group in the Manufacturing Systems Integration Division at the Manufacturing Engineering Lab at Nist. He worked on, he did research on the standards for interoperability of computer-aided design systems. Before that, he was in the faculty of MIT for almost 8 years, and then he set up the Intelligent Engineering Systems Lab there. I mean, he's published lots of papers, over 300 papers, and he was the founding editor of AI and Engineering. And he's got a whole bunch of awards from almost every society, from mechanical engineering to bioengineering. And he's a fellow of AAAI, American Association of Aeronautics, I think, biomedical engineering, mechanical engineering, AAAS, and so on. Was also president of the Washington Academy of Sciences. And more importantly, he is a distinguished alumni from IIT Madras. He did his MS, IIT, BTech in IIT Madras, and then MS and PhD from Carnegie Mellon University. With that, Ram, I'll hand it over to you. Please go ahead and start your lecture.
Thank you, sir, for that introduction. And actually, I've known sir for more than 4 decades, to be precise, maybe 43 years. A lot of you have probably not been born at that time, but that's a different story. And I'm going to share my screen now, Saab. Is that okay?
Yeah, please do.
So anyway, my name is Ram D. Sriram, and it's my pleasure to give this talk here on the role of Nist in standards development. And normally, people think standards is kind of dry stuff to do, but let me see what I can do here. And as you can see that little cartoon out there, I mean, the whole world is operating because of certain standards working well in terms of the wireless standards and the communication standards, especially shows so much so in Europe. I have a lot of slides here. I'll probably won't go through all of them. Some of them I may be skipping through. I will give the slides to Sab, so in case anyone wants it, he can get it from me. A big background of Nist, where I work. The National Institute of Standards and Technology is a part of the Department of Commerce, a federal government agency in the United States, with several Nobel Prize winners here. We have basically physical locations at Gettysburg and Colorado. And the main mission of Nist is to promote innovation in the United States and industrial competitiveness by advancing measurement science, standards, and technology in ways that enhance economic security and improve our quality of life. Now, I talk about promote US innovation. Now, we actually promote US innovation by also collaborating with other people from other countries also. It's not only a lot of work that we do, we work in collaboration with a number of other countries who have similar goals as us. But our focus basically is in measurement science, standards, and technologies associated with this, as you'll see. And the main priorities for NIST right now are critical and emerging technologies leadership, as you know, AI, quantum, and those kinds of things, leadership in standards, leadership in manufacturing, and we do a lot of community building and so on. So in terms of the critical and emerging technologies, AI is a big thing right now. Biotechnology, cybersecurity, energy technologies, quantum information science, and advanced communication. So, and we kind of work in standards and measurement sciences associated with each one of them. Okay. And in terms of the standards, and I'm only going to focus, NIST does a lot of things. And if I were to talk about everything, it'll take me days. And you can go to the website and check us out. So in terms of the standards leadership, NIST leads execution of the US government's national standards strategy for critical and emerging technology and the developments of federal standards policy to ensure continued US global economy competitiveness and technology leadership. Again, as I said, that we are focused on US innovation, but again with help of many other people too, and it's really good for the world. So if you look at again carefully, the US economy depends on Nist measurements. So at the bottom level, you have applications, and that's a final thing anyway. But that's kind of for these applications, we need standards and calibrations that traceable to Nist, and then we have derived units which are maintained by Nist, and you have the basic units. As you know, there are 7 basic units like time, length, mass, temperature, electrical current, light intensity, and amount of substance. Now, one of the fundamental problems that you see right now with these units is the lack of a proper consensus around the globe in terms of use of units. Like, for example, in some parts of the world they use feet, in some part of the world they use meter. So this and then it also ended up in disasters like what happened about almost a decade ago when they sent uh, uh, a satellite or something, not satellite, so they sent
Mars rover.
sent something to Mars orbiter or something like that, and it crashed. And the reason is they were using incompatible units, and that's a big problem of lack of compatibility across these units. And NIST tries to kind of be maintain this basic. These are all physical units, by the way, what you see here, but they're also informational units, and I'll talk to that later on because I am in the information technology lab. As you can see, the organization. I'm just gonna. There's a lot of things we are doing in manufacturing. I'll talk about these things later on. But in terms of the NIST leadership team, we have Director Laurie Lacoscio, and then I belong to the laboratory programs, where Charles Romain is the associate director for lab programs. And there are about 6 labs here, and I won't go into each of those labs, but every one of them of these labs are involved in basic measurement science and standards and technologies associated with that. I belong to the information technology lab, and in our particular lab, there are several divisions with computer security, information access, software and systems, statistical engineering, mathematics, and there are two security divisions around here. Security is a big thing at NIST, and I am the chief of the software and systems lab, and here is a organization of my particular division. Again, the idea is not to talk too much about us, more than about the standards, and you can get the slides from Sab. Our budget is about about $1 billion or so, and again, we have about 3,400 employees, and we also have a lot of people called associates. What we have people from all over the world working with us as guest researchers. We have local domestic people working with us as domestic research associates, and so on. So we have a lot of people working on several things, about 5 Nobel Prizes so far, and there are 1 or 2 which are kind of indirectly related to NIST. Okay, that's a very basic background of NIST for those of you who don't know what NIST is all about. Now let me go to standards. Now, in terms of standards, actually there's a standard definition. As you can see here from ISO IEC guide, there is a, for those of you familiar with the ISO, which is a standards organization, and a lot of standards come out from here. So they produce this document which gives a definition of a standard, and they claim it's a document established by consensus and approved by a recognized body that provides for common and repeated use, general rules, guidelines, or characteristics for activities or other results aimed at the achievement of the optimum degree of order in a given context. I don't want to read this thing, but you can see what in other words, what really this is. These are all documented agreements containing technical guidelines to ensure that materials, products, processes, representations, and services are fit for presentation. And the idea is that that people can interpret them in a proper manner. And this is a thing that Bob Allen and I we wrote a paper called "Role of Standards in Innovation," and it's taken from there. And so this is something which Sub gave me some time ago in terms of evolution of standards as such. That is, as you can see that the society, the civilization, as it went from hunter-gatherer to the information systems age, standards have actually become a very important part of it. Like, for example, if you talk about technology, in the hunter-gatherer era, the language was a major means of communication. And you need to have a proper standardized language so that you can communicate. Similarly, when we went into the agrarian society, people were having fields, and they were maintaining agriculture and so on. So the people had to measure the various things, and so standards were important for measuring, and not only for measuring but navigation too. Okay, so for miles, meters, and all those things came into picture at the time, or kilometers, whatever you want. So then when industrial era came into picture, we had the notion of powered machines, and these machines also had to be compared. Standards became very important. And now we are in the information era, and then information era, we have what are known as the linear processes and the adaptive processes. And if you take your email, for example, you're kind of just sending email to people, and that email has to be, and interestingly though, you don't think about it, but this email goes from here to India in a matter of, I don't know, speed of light, I guess, whatever you call it, the speed of electrons. So they go so fast. But then they kind of, it's all, the reason why all these things happen is because of appropriate standards put in place. And then we are going into this whole era in a completely new, the world is evolving, and there's this whole notion of the adaptive processes with all kinds of AI and those kinds of things are evolving. So we need certain standards to make sure that we interoperate properly. So the standards have a history. Because of standards, lots of things are happening. Innovation is happening because of standards, as you can see. And this innovation requires standards. You like it or not, we'll come back to that later on. So to classify one way to classify standards, there are several ways of classifying, but this is one particular way that we came up of classifying standards. And the first one is called the measure or the metric standards. And that is the one that I talked about very briefly before in terms of units and measurements. And this particular thing is a standard which is like a measuring mass. The kilogram is one of them, and everything is there's a standard kilogram, I guess, somewhere in there's one in France, one here at Nist, and you compare everything to that. Now it so happens, interestingly though, that most of these standards, the physical standards, are now being actually recast into electromagnetic radiation. For example, meter is measured in terms of speed of light, and apparently in the future kilogram also will be done, and there's something called the Planck's constant, and Nist is very actively involved in that. Again, I don't want to go into this. These are all measurement, the physical measurement standards. And if you go to the Nist website, which I probably have a pointer to it somewhere, that's shown there. Then you have these are like the kilogram, meter, all these things are the standards for measuring things. Then you have prescriptive or process standards. A number of times what happens is that you don't really actually, the way that you have the standard is you have define a particular process, or you kind of prescribe the things. For example, what you can do is that you provide a methodology to perform tests and perform processes in a consistent and repeatable manner. Okay, an example of this is the American Society for Testing and Material, ASTM, that's C1028, I believe. And it has something like a standard test method for determining the static coefficient of friction of ceramic tile and other like surfaces by the horizontal dynamometer pull meter method. So here what you do is that we don't make any judgments here, but then we tell about how the results of the friction test should be interpreted, but we only prescribe saying that how this should be done. And for those of you in the cooking world or interested in cooking, the recipes are like a prescriptive kind of things. So these are essentially recipes, but they're standardized recipes which one can follow. And in the performance-based standards, processes are not specified, but ultimate performances. Like for example, if you're talking about buildings, in a earthquake resistant, you can say that the particular building has to resist a wind force, a certain wind force, like maybe 160 kilometers per hour or something like that. That particular thing has to resist that way. So this is very important, because all you specify is you don't care how the building is built, but you care that the building has to withstand this uh, these forces. You got to be careful sometimes. Actually, I was once in Hyderabad, and I was in a particular building which was very well built, but then there was water all over the floor. And I asked the person, why is there water all over the floor? And the person said, well, the problem is that this building can maybe stand earthquakes, but no one specified that no, there shouldn't be water leakage from the top, because apparently it didn't at that time rain was not a big problem. Now it is, of course. So then it was not, there was not proper performance based standard out there. And so these are some of the kind of problems we face of not specifying things properly. And finally, we have what is known as the interoperability standards. And these actually are both in the physical world and in the information technology world. Like in the physical world, you'll see many times in automobiles and things like that, you have interoperable nuts and bolts and those kinds of things. Can be so you can you can take out one particular bolt made by one manufacturer and replace it by a bolt made by another manufacturer. So this is the physical interoperability. But we also have what is known as the information based interoperability, especially with the CAD CAM systems right now, where these systems have to interoperate with one another, and we'll come to that later on. So these are the four. Pardon? Maybe people may want to mute here. And so one way to classify this, that's one way to classify the standards. I gave you four particular ways. And then you can kind of, this is one dimension for standards, and there's another dimension which says where do these things fall into, what kind of categories. You have these de facto standards, like for example the QWERTY board that we use became a de facto standards. Microsoft Word is becoming a de facto standard right now for many people. Then I mean, these standards are not really developed by in any consensus manner. However, they become de facto by usage. Then you have the regulatory standards, which the governments kind of pose. And so, for example, in the safety standards are a big thing, where the government says that these are the standards that you have to follow. And similarly, industries may have their own regulatory standards, but generally regulatory standards come from the governments. Then finally, we have the consensus or the voluntary standards, which is what we will be focusing on right now. And these are done by people, various people acting in a voluntary manner to develop these standards. Okay, so this is the it's a documentary standard. Remember, we talked about documentary standards, and this is a documentary standards. So the focus of this presentation are voluntary consensus standards. We won't go too much into the measurement kind of things, physical measurement standards I talked about. Again, I belong to the information technology lab, and I focus on the information technology aspects of things. So now, so these are, again, this is a voluntary standard, is optional. Now, in terms of the information technology, we can have a typology of these IT standards, where at the lowest level, we have this standards for implementation languages like C++. And then you have some things called information modeling language, like you have XML, UML, and those kinds of things. I mean, there's a wide spectrum. You have languages such as, for if you want to represent semantics, you have things like OWL and RDF. And then you have information modeling languages like Express for that's used in the mechanical world in STEP and so on. Then you have what are known as the content standards over it, which is the one I talked about, STEP, where STEP is actually the language for STEP is Express. So, but this is used for interoperating between CAD systems. Then you have the architectural frameworks like DODAF and FEAF and so on. So there's a lot of acronyms around here. So essentially, if you're looking at interoperability, the ideal goal is to build systems which are self-integrating. Like, in other words, I go take my computer and plug it somewhere, and it automatically interoperates with the with any other device anywhere else in terms of at the application level. Okay, these are self-integrating systems. They can integrate themselves. To do that, the system has to describe itself. So system has to tell the rest of the world what it does, how it does it, and things like that. So semantics have to be explicitly done. So we need to have explicit formal semantics. And finally, what we have nowadays are the common models of data. We have actually achieved this particular slide was done about 20 years ago, and one might ask a question, where are we now? We have actually done a reasonable job of developing common models of data and developing explicit formal semantics, especially with RDF, OWL, and those kinds of languages. And at some point, maybe Sub will talk about a thing called category theory, which is again a system for representing uh, semantics in a formal manner. So we are getting there. It's going to take time to do fully self-integrating systems, that is at the application level. So that's a very basic introduction of standards. So why standards? Now, so I gave you a very brief overview of the what are the various kinds of standards you can have, various category standards you can have, and then I talked a little bit about the interoperability standards and the notion of self-integrating systems. Okay, so why do we need all these things? The reason why we need this is standards contribute more to economic growth than patents and licenses. Because things were standardized, we could do lots of things in a economic manner than or in a price efficient manner than we could do before. And that's kind of and most of you probably have are realizing this in one form or other. Like even if you take the USB port that you have, and that allowed a lot of things to interoperate in a way physically. Or if you take the your what is the other one, like the Apple. Of course, Apple is the operating system is proprietary, but there's a lot of things in there which are standards based, and uh, the interoperability of CAD systems is happening because of standards. And there's an interesting thing, because
Just a
suppose,
comment, your computer has 150 standards operating in them.
pardon?
Your computer has close to 150 standards operating in them.
Yeah, actually, that's you're right. And in fact, I had a slide which I didn't put it in there. I'll add it onto this thing. I have a slide of this Boeing, the Boeing aeroplane, for example, the aircraft. It's very similar. They have probably a few hundred standards in there, flying together in unison. So that's why standards are very important. Because of standards that Boeing aircraft could potentially fly in a that we are risk-free manner in a way. Okay, transporting people from one part to another part, and it's all because of standards. Okay, and so anyway, there are a positive stimulus. The idea is that for innovation, standards are very important. Okay, and so if in terms of the United States government, now the thing is that US is interesting, interesting than the other many other governments. Here we don't really enforcement is not so much a thing around here. We believe in voluntary consensus standards. Okay, so we believe the standards have to be made in a voluntary consensus manner, and we in fact the government actually wants us to use those standards which were developed in a voluntary and consensus manner. And there are a number of things around here uh, which are there's a National Transfer and Advancement Act and so on and so forth, which kind of clearly specifies that. Okay, now however there are exceptions to this, and we will talk about some of the exceptions of using non-voluntary standards in a way. Okay, now here is what are the standards ecosystem. As I said, the US standard system, it differs significantly from government driven centrally coordinated standard systems common in many other countries. Okay, so and there are hundreds and hundreds of standards developers around here. And the US government personnel participate in standards developers activities along with representatives from industry, academia, and other organizations. Again, I'm giving you a perspective of the US standard system. I don't know, India it may be a little different on how standards are developed there and maintained. Uh, Maybe in India, the government plays a larger role in standards development activities. I don't know. But definitely in China, the government plays a major role in the standards developments. So we have in the United States something called the ANSI, the American National Standards Institute. And this is a federation, it's a private sector federation that facilitates voluntary consensus standards and conformity assessment systems. We'll come to conformity assessment later on, because once you develop a standard, that standard has to be tested, and whoever uses that has to make sure that they are in conformance with that standard. That becomes very important. Now, ANSI accredits around 200 standards development organizations. Okay. Now, then ANSI is also the official US representative to the International Organization for Standards. Also, standardization. ISO, the acronym is ISO, but really it's International Organization for Standardization. It's not IOS, but it's ISO is the acronym they use for this International Organization for Standardization. And ANSI is the primary representation from United States. And there's an MOU between ANSI and Nist, which recognizes ANSI's national and international roles. So then I said Standard Development Organization. What is this? It is an organization that develops and approves documentary standards using various methods to establish consensus among its participants. Again, there are many standards development organizations in the United States. Okay, and there are some like, for example, you have I guess NIST ITL also is one of those accredited, but we'll see why. There are international private sector based one like ISO, IEC, IEEE is a standard development organization. You can have international consortium like OSIS, IETF, and W3C. Then you have some government agencies like NIST, and they have very specific roles. Sometimes this membership, sometimes they are open, sometimes they're closed. Many times, if you want to get standards developed by us, ISO, you may have to pay a fee for it. And some are free. Now, after I described what standards are, what is the ecosystem for the standards in the world, what are standards development organizations, now I'll briefly talk about the NIST ITL's role. Now, it's kind of interesting. I want to have two quotes in here. One is by a previous NIST director in 2010, Pat Gallagher made this statement. And he said that about 400 technical experts from NIST participated in almost 1100 standard related activities in more than 100 standard development organizations. And you can see the scope of that. So the main thing you wanted to emphasize there is that NIST brings to the table a breadth and depth of technical expertise, a reputation as an unbiased and neutral party, and a long history of working collaboratively with the private sector. Okay, so there are a lot of things in this particular statement that he had said. One is that we have the breadth and depth of technical expertise at NIST, and we are unbiased and neutral party. We are viewed as a very unbiased and neutral party by all organizations. Again, there are a number of instances where, because NIST did something, even in the courts, the judgment changed because they view NIST as an unbiased and neutral party. And we work very collaboratively with the private sector. Then recently, about last year, Jim Althoff was the NIST acting director. I guess in a testimony to the Congress, talked about again the role of standards. And then he can see here, he said, now it is made possible by the participants of 570 NIST technical staff. And now we are in over 300 standards organizations, which was 100 before. And there are more than 3,000 different standards activities. So you can see that in the last decade or so, our participation in standards has increased dramatically. There's one more thing which is called the Federal Information Processing Standards, which came out of something called the Brooks Act. And what some of you are interested in it, you can Google in the thing. And this is for probably used by the federal government. So these standards were supposed to be used by the federal government, and then this is approved by the Secretary of Commerce here. That's NIST belongs to the Department of Commerce. So these are developed by NIST ITL on an exception basis, okay? Because we don't really develop because of the federal requirements of a federal government, we develop these things. Okay. So these are not applied to national security systems, but are mandatory for many federal systems. These are not voluntary consensus standards, but again, what has happened? But then what happens is that when we developed a FIPS at Nist, it becomes a voluntary standards later on. Like for example, the FIPS 197, which is an encryption standard, became the ISO IEC 18003 standard. So the many of these FIPS standards kind of deal with cybersecurity. Again, you go to the Nist cybersecurity, you can see those things. So at one time we had about 200 FIPS. Now we have about only 9 FIPS. So we don't really get involved in too many of these activities as such. Okay. So, but our main activity at Nist is in the SDOs. Okay, as you said, we participate in so many of these standards. I mean, even from an ITL, from the Information Technology Lab, which I work in one of the again goals is to work with the standards organizations. Okay, and we at ITL have published a lot of reports, and these reports eventually go and become go into international standards, and sometimes in, like for example, in the FIPS case, we become federal standards. So I'm now going to. So then, many of them are in this ITL Nist publications. For those of you interested, you can go to the Nist website, go to the publication site, and you can see a lot of these things. Now we have something called the Nist special publications. So these publications we have are very specific. Basically, most of them, there are 2 types of special publications: the 500 series and the 800 series. The 800 series is very, very specific to computer security, and there are about approximately 170 publications there. Again, some of these things like the Nist special publication 800, the BIOS protection guidelines has become an ISO, IEC, so on and so forth standard. So a lot of things, like for example, similarly for the 500 series, the cloud computing reference architecture has become an ISO standard. So in other words, there's a number of reports that we produce, special publications, which eventually go into international standards. Okay, so one of the things Nist produces are this called interagency reports are internal reports. They're called Nist IR series, and again, there are you have to go to the cybersecurity standard strategy. You can look at 8074 volume 1, so on and so forth. So there are a number of this. There are about 2,000 and 3,000 NIST reports, and Sub was actually participant in a number of these NIST IRs too. Okay. So ITL is an ANSI created SDO. I don't want to go too much details into that, but ITL is actively involved in that. One of the things that I mentioned is that once the standards are developed, once you have a particular standard like the STEP standard, the cybersecurity standards, or any one of them, you also have to have associated with it what are known as the conformity to the standard. So that is done through testing process. So then what you do is that if someone says that they have implemented a particular standard, and let's say you're trying to sell a good, and the government says that your particular software should conform to this particular standard, how do you know it does it or not? And that's where conformity testing comes into picture. And NIST actually develops a number of tools for doing this conformity testing. So you have a number of these tools that NIST does. Health IT test tools are one of them. Then they have software assurance test suites, which are 2 of the suites which come out of my division. Then you have this advanced encryption standard algorithm testing. So what are the pragmatics associated with the standards development? Now, the standards are continuously evolving, as you know. And it's very important for countries to participate in the standard development process. I'm not sure whether India has a national standards strategy or not. But if you were to compete in the global markets, it's very important that you have to participate in the standards internationally and nationally. Such, like for example, the Germans developed the DIN standard, which is used in a number of this again a physical standard, which is used in a number of countries. Again, in the internet, we have TCP and those kinds of standards, which made communication across different communication systems possible. This evolved from United States, but then eventually it became in fact, Windsurf was one of my mentors. Is the father of this TCP/IP. So these are the kinds of things that are important for us to compete globally. Uh, as you can see, that there are lots of standard development organizations. So there's a Darwinian competition going on there. Now, the standards developments for many companies is a voluntary job. Okay, you do it because it's very important for your organization. So some companies like Boeing, IBM, and all of them, they have people working in the international standards organizations on a voluntary basis. Okay, the other phenomena that is happening is in computers, or if we call it information technology, whatever you want to call that, the costs and profits have shifted from hardware to software. To services is part of software anyway, like cloud computing and things like that. So software standards are becoming extremely important now. Okay, so there is even, like, for example, Boeing or Airbus, whichever you call it. Okay, the aircraft. In the future, the cost of an aircraft, the software cost will be much more than the hardware cost. Okay, now the software cost will be much more higher than the than the hardware cost. Okay? You have to keep that in mind, and this is very important that one needs to be keep up to the current standard development activities. So what are the motivations around here? One, we have the consumers and the providers. The consumers, one, are the people who are consuming the information technology goods, the software goods. Then the IT providers are the providers who are actually providing software, either in the United States or in India. They are providing software for the consumers. Now, consumers want to avoid locking to one provider, because if it's a single provider, like, for example, let us say if Microsoft Word is the only word processing system, actually, you can see, then there is this problem that we have with many of the systems where the antitrust comes into picture. Okay, there's an antitrust legislation in the United States in terms of the dominance. That's why you have some other pieces of word processing systems too available. Okay, a single word processing system cannot dominate, although Word is becoming a de facto standard. But the idea is to have freedom to use other things. Like, for example, you have I think the Linux people have their Microsoft software available. Similarly, in the word processing world, LaTeX and those kinds of things are there. Okay, and even for the IT providers, it's very good to have this voluntary consensus standards. So for the consumers and both for the IT providers and the consumers, standards are very important. Okay, for IT providers, so that they can compete in the global market. For the consumers, so they can get the best pricing deal. And as a result, innovation also happens because of that. Sometimes you have standards take time. Sometimes they're very fast, as you can see around here. It all depends. Like, for example, the DHS, the Department of Homeland Security, there is the Registered Travel Interoperability Consortium specification in 2006. It took 4 months to produce that. The FIPS 197, the advanced encryption standard, took about 5 years. But then, going from FIPS 197 to the ISO IEC 180Z took about 3 years. So it all depends in terms of the. There's a lot of factors go into the standard going from where it started to being realized. Okay, now I have about 10 minutes or so. There is a lot of case studies here. I'm going to kind of go very fast in these case studies. There are case studies in healthcare, manufacturing, Internet of Things, and cybersecurity. So in terms of the healthcare is an important part of the economy. In the United States, we spend about $4 trillion in healthcare. Now, India's GDP is almost $4 trillion, but however, you cannot compare Indian GDP versus American GDP, because the cost of living and other things are very different in India. But anyway, you can see the scale here. So one of the see the way this operates, that again, this is a report which I was involved in producing, called Procuring Interoperability in the healthcare world. So you see that there are several layers here. At the macro level, you have big hospitals and all talking to one another, and then you have within an hospital, things are talking. I mean, systems have to talk to one another, and then you have at the point of care, where you have in the hospital, there's a lot of information coming out from hospital rooms that have to be interoperated with other rooms and so on and so forth. So this is a scenario that is in United States. And India, I don't know how much happens in terms of interoperability across different hospitals. Okay, because I know there the problem is that many of multi-specialty hospitals want uh, everyone to be there. They don't want to go to their patients to go to some other hospitals. Okay, not so in United States. So what happened in United States is about several, almost 1.5 decades or so, the government decided that there's a lot of waste of money happening, because lack of interoperability was costing billions and billions of dollars of waste. And the reason is that someone goes to a particular hospital, they get an X-ray, and then they go to a different hospital, the X-ray is repeated again. So there is no interrupt. Similarly, doctors used to write things on uh, charts, handwritten notes. No one understood what it is. You send it to a hospital, to the pharmacy, a prescription, and the pharmacist couldn't kind of figure out what the doctor is giving, whether he's giving a Celebrex for arthritis pain or Celexa for depression. So those are the kinds of problems that we were facing at that time. So the government decided that all the hospitals will have to, all the doctors will have to interoperate, and they came up with this notion that every doctor should have electronic health records. Again, electronic health records are there in India, but they're not used very much for documenting the patient's history. So there are a number of issues involved in the electronic health records. You have to first input, you have to store, that's a representation and persistency, and then you have to manipulate. Now, in terms, it says interoperability, because you got to exchange information, both syntactic and semantic information between various electronic health records. And finally, security becomes very important, because all the information has to be passed across in a secure manner. Interestingly, though, like for example, a person lives for 80 years or so, average life. You have to have information that you store across this lifespan of 80 years. And the same thing occurs in the manufacturing world too. We'll come to that later on, where if you have a Boeing aircraft, let's say the life cycle is 80 years, you have to have all the information stored for 80 years. Such, how do you store it? Different story. So there's a lot of issues involved in there. Let me, in the electronic health record world, you have the electronic health record, but then you also have information coming from the laboratory information systems, from the public health. Then you have medical devices are giving out all kinds of data and information that has to go in. Devices have to talk to electronic health records, and devices have to talk to devices. So there's all these interoperability challenges in there. There's also, again, I'm not sure how many of you are into medical field. I don't want to go into too much of details, but there's a big problem in the medical world in terms of the syntax and semantics. Like in one of the vocabularies that people use, popular vocabulary, is this UMLS, metathesaurus. And for example, if you have this disease called pituitary gigantism or hypersomatotrophic gigantism, it is that those people who grow very fast, very big, they're 7 feet, 8 feet, and things like that. And that's because of a disorder in the pituitary gland. But it's known as different terms. Like, for example, if you go to de-explain, it's called one thing. SNOMED, it's called something. So different vocabularies use different terminology. And same thing happens in again, the manufacturing world too. So you have to interoperate both syntax and semantics across. So standards are very important to achieving this interoperability. Again, just because a system says that I have implemented this particular standard doesn't mean that particular thing is in conformance with the standard. In a sense, you got to test it. Okay. So there is a lot of problems, challenges with this IT interoperability standards. I don't want to go into too much details, but I say that, yeah, there are problems. And these are all the standards right now we have available for doing it. We have things like for pharmacy, NCP-DP. HL7 is a one which is used quite a lot. And again, I don't want to go into details of HL7, how it looks like. But that is a medium over which the syntactic standards were built. Some semantics too. And these are the standards in healthcare right now. For terminology, we have SNOMED and LOINC for the laboratories. Then we have ICD-9, ICD-10, and devices, we have IEEE 11073. Then we have for images, DICOM. Again, for interoperability, HL7 messaging. Then there's a language formats in XML, X12. Then we have internet protocols, and then we have something called the FHIR standard now, which is coming out. So if you look at the interoperability, you can see that the lowest level is the technical interoperability, and the highest level is the organizational interoperability. And standards, there are standards at various levels. Okay, and I'm going to just skip through all of these things. And in terms of the Nist activities, we participate in a number of these things. There is a Health IT Standards Committee, which I'm part of at the national level. Then we have a number of people, my folks, working on different aspects like HL7. We do a lot of work. And I'm going to now skip many of these healthcare slides here, because we have what is known as the Act 21st Century Cures Act, which was passed by the Congress. And it says that the national coordinator here in United States shall work with Nist to make this happen. And Nist is the one. So what happens is that here, a very brief summary here is that if you go to a doctor in the United States, and most doctors will have to use the EHR right now to get reimbursement for their services, and that EHR has to be certified for that's it's compliant, and all the tests for certifying that EHR is developed by my division at Nist. So that's briefly. Okay, so I'm going to kind of and this is the one that we have a test framework that we have developed, so that any of this once you have the electronic health record, and that has to conform to a set of standards, and these standards will have to be tested, and we have a test framework to do that. So I'm not going to go through these things, except that we have the test technique because interest of time. Now, one of the things that happens is that you have it's like the plumbing system. So all the standard things have to interoperate across the ecosystem. Remember, I showed a slide of at the hospital level, at the organizational level, at the local level. So it's like these pipes going on, which are connected to one another. And then what we do is that we kind of poke in and see if any of those things are leaking or whether they're robustly built. It's like the plumbing system. And the second thing is manufacturing world. Now you can see that the manufacturing world is very similar to the healthcare world, where you have basically the input, you have to store, representation, persistency. Then you have this notion of solving, where you do analysis of finite element analysis and those kinds of things. And then you can manipulate, where you can create new knowledge out of the old knowledge. And again, here you have interoperability between design to design systems, design to manufacturing systems, and so on. So design to design, design to manufacturing. So security again becomes a thing. So manufacturing is very similar to healthcare in this world. So in fact, Sub is also involved in here, where we talked about how do you map both from the healthcare world to the manufacturing world. And here is an example of the kinds of knowledge that I'm only talking about design around here, that while you are doing a design is generated. And there are different representations. Like if you look at design, going from required modeling to detailed design, you'll see that you have the voice of the customer is linguistic representation. Then you have ontologies which are symbolic in nature. Then you have geometry when you go to detailed design. That's a different representation. So you have representations going from linguistic to pictorial, symbolic, algorithmic to virtual, to back to linguistic and symbolic. And this is something which Sub probably can talk a little more about it later on. That is, the idea is that when you are talking about interoperability, there are several things in there. One is that you have to represent your content in a particular way and using a particular language, and that language has to be pretty expressible as such. So this is in the manufacturing world, and this is which is Sub wrote a paper a long time ago on this, and maybe we can talk at some point on various things. Again, it's a very complex area. We were working on it for more than 2 or 3 decades, and you can see that these are some of the standards like STEP, which is basically for exchanging geometric information. And then there's a lot of things which involves in design and manufacturing, which is information based. There are not really that many standards, but they're still evolving, especially for life cycle information. And this is the overall landscape of this particular standards, which Sudarshan produced a long time ago. So anyway, I'm not going. There's this AP203, AP233 in STEP. There are product-based standards. They're for processes at the enterprise level. So they're different. If you see this XY axis, there's a product, process, and enterprise services, and then the life cycle of the design manufacturing world from ideation to disposal. And you can see a map of these standards. Okay, and this is something that at Nist we have developed a representation which can capture the entire life cycle. And Sub was a major part of this thing, and it's been used elsewhere. So I'm not going to go now talk, since we are running out of time. There are a number of these things like the Internet of Things that is happening right now. There's a lot of standards again in this particular world. And if you look at the IoT related activities in SDOs, you'll see that in the United States we have ANSI. And don't worry about all these numbers. You can see, you can just Google and see what these things are. But there are some subgroups that we can work on, like SC 41 is IoT, and it's part of ISO, IEC, JTC1. Now, all this looks like mumbo jumbo to many of you, but that is part of the standards ecosystem. But you have to remember there is an IEEE, there's an ISO, there is IEC, there is IETF, and there is ANSI in United States. If you are in the international world, maybe you'll probably be mostly working with this ISO or IETF or IEEE. I'm skipping all the cybersecurity things, the lack of time, but you can. There's a lot of, again, these are some cybersecurity standard developers in the international world, and then you have the US counterparts like the ANSI, and then we have X9, INC, ITS, and then there are all these acronyms, and you can Google and find out. Okay. So in terms of just, I want to summarize, take about 5 minutes or so. So you have 3 types of things are happening here. One is the IT providers. We call it as the first party who are providing IT services. Then people are consuming this, like let's say you have cloud services. Amazon is providing you cloud services, but then you are actually using the cloud service. You as an individual may be using, or your organization may be using, and you will be a part of an organization is using. Then there are the standards and test tools. So so the standards being developed so that everything is interoperable and so on. And so then you also have to have test methods to make sure that the standards are conformant. So then there are several types of testing. The first party testing, that is the providers themselves then test the things. And the second party testing is that the consumers now do the testing at their own labs. And then the third party testing, which happens quite a lot, where you have certification bodies and accreditation bodies. Like, for example, when you talk about the electronic health record, there is a third party testing. That is, the testing is done by sub-accredited labs who actually use the test tools which are developed by Nist. In other words, if there's an EHR vendor, the EHR vendor, we don't directly deal with the EHR vendor. We only develop the test tools and give it to a third party, and third party deals with the EHR vendor here. So EHR vendor is the first party, and we are we develop the test tools, and there's a third party which actually uses our test tools to test whether this particular EHR is in conformance with the appropriate standard. Okay, so in other words, standards in general, they enhance compatibility, facilitate interoperability, reduce technology risk. Okay? And one of the things which people don't realize is because standards, they spur creativity and innovation. The chromatic scale of music and its formal notation system spawned 2 centuries of the most prolific and original composition. Because there was there was standardized notation, innovation happened. That's why we could get all kinds of original compositions over the last 2 centuries. The number of trends in standards in recently, for example, artificial intelligence, post-quantum cryptography, semiconductor manufacturing, the CHIPS Act, and then there's a lot of frameworks for standard developments. And there was an interesting paper that Nist put out by Sudarshan et al. On using the Zachman framework as a framework for standard development. And I think Sab will talk sometime in the future, talks about some of the works he's been talking about, a framework for standard development. In terms of AI, there was a National Artificial Intelligence Research and Development Strategic Plan 2023 update. And in this report, there are several places which talked about standards for AI and benchmarks, data, and all kinds of things, and what should be done there. And I'm one of the authors of this report. Recently, President Biden has put out an executive order in the last week or so. And it came out on October 30th, 2023. So actually, 2 days ago. And it directs Nist to develop guidelines and best practices to promote consensus industry standards that help ensure the development and deployment of safe, secure, and trustworthy AI system. So what is going to happen? I'm just talking about this because this is the trend in the future with what is happening in AI. And there's a lot of issues involved with artificial intelligence per se in the world. People are worried about that AI is going to have a negative impact in the world. But one has to understand that any technology that is produced in the last few hundred years has had an impact, both positive and negative. So the idea is to enhance the positiveness of this and mitigate the negativeness of that technology. And that should be the goal. And AI is very similar too. And AI is a new technology. Actually, it's not so new. Sab and I have been working on this for like four decades or so, but that's a different story. There are different waves, and we are in one wave right now. It's called the deep learning wave. So with this particular perspective, our director, Laurie Lacascio, kind of talked about it briefly in terms of how Nist is going to explain the role of Nist in this whole thing. So one of the things that we have developed is called AI.
You may want to close down. It's almost
okay. So I'm going to close down again, and there's a chips R&D thing which is for semiconductors. So essentially, this is one of the roles which Nist plays. There are software developers. This is in the manufacturing world, manufacturers. So we kind of work on interoperability testing, conformance testing around here. So in terms of how do I need to, so you can answer these questions along with this. Again, I don't know too much details. And just for fun, there was a recent video on Saturday Night Live, and this is something which you may want to watch about metrics and the systems US uses. Okay, I think I'm going to end now.
Okay. Yeah.
Can you hear me?
Yes, we can.
Thank you, Professor Ram. This is excellent talk, very informative. I have a two-part question. One, you mentioned at the outset that the role of standards in maintaining and building the leadership of a country or economy. My first part of my question is, what are the areas of standardization in which US has not done well or has to catch up with other countries? Second part of my question is, since most of the audience of this talk is from India, what is your assessment, if you might be willing to share, about the
Are you all hearing a
progress of,
background noise here?
standardization in Indian IT industry. How is it doing? Is there any serious effort, and how is progressing? In other words, is Indian IT industry using standards for building its leadership? Thank you.
Okay, great questions. In terms of the United States, as I said, that we are a voluntary standards participation in there. So it all depends. So sometimes, yes, like for example, we try our best. Again, we try our best to actively participate in the international standards, as you can see in the codes from the previous Nist directors. Okay, so in terms of where we lack participation, is something is a political question for me. I got to be careful on what I answer. I come from a standards organization around here, but again, we try our best to be part of the voluntary ecosystem as such. So that's why we have so many hundreds of standards organizations going on around here. But that's why we are trying. There is a president's executive order about artificial intelligence, because we want to keep the AI. We want to be in the forefront in AI, and we want to mitigate risk in AI, and that's why the president's executive order came into picture. And the one of the things that this particular order brings is put standards in front right now rather behind. Okay, so that will mitigate risk associated with AI development. Okay, again, going back to, for example, China is really advancing a lot in AI in certain areas, especially in facial recognition and those kinds of things. So the key question that is asked is that will be US be behind that? Okay, and the answer to that question is that we have to be one step ahead by develop both technology and ensuring that the risks associated with this technology are mitigated, and that's one of the reasons for the president order. So I know I gave a political answer, but that's where we are at. And in terms of the second, and actually, in fact, Shamsundar, related to that, I think there should be more emphasis. That it's again a question of funding how much funding that is provided for this too. So I think that in the future, unless again, this is a personal thing, not Nit's position, I think that we should particularly, the two things that should happen. One is that the government itself should put in more resources into the standards development. Two, the academic world, actually three, that academic world also should get into the act, because if you look carefully, you can get a degree from any of the top universities and have no idea about what a standard is. Okay, most of these academicians are clueless. So that means the universities also have to come forward and provide courses in standards. I think Mellon was doing something like that. I don't know about other universities as such. And the third part of the industry also has to put in effort into that thing and put in resources for participating in this voluntary standards participation. So that is from a US perspective. From an Indian perspective, actually, I'm not sure, because one thing I know, they don't enforce healthcare interoperability as such. Okay, because I've gone there. Hillary Clinton went to India about 10 years ago and went on it after that on a delegation from ITO, the trade office here, and they surveyed a number of hospitals and so on. And they didn't really have anything, and most of their EHRs were focused on billing centric view. Now they've probably changed and become more patient centric, because EHRs could be either patient centric or billing centric. So now I think there is a trend, they're changing towards the patient centric kind of EHRs, but that's very difficult, because what happens in an electronic health record is you have to input all the history and physical, and the patient comes, and the doctors are so busy in India, they don't have time to input these things. So unless there's a new technology of inputting this into the into the EHRs, those are going to be slow. But what they captured very well are images are captured, especially in gastroenterology and so on. Those images are captured and they're kept somewhere. And so there's a vast amount of India is sitting on a gold mine of data in those things. And in terms of the manufacturing world, again, it all depends. They probably, especially if you're doing CAD systems, you may have to be in conformance with some of the international standards associated with it. But again, one of the claims for some of the CAD vendors is that why do we need to do that? You tell us in what CAD system that you want the information in, and we will give it to you in that CAD system. Why do you need the standards for interoperability? Because our labor is cheap.
I see Dr. Kota Harinarayan. Do you want to add something from the Indian side, Dr. Kota?
Dr. Kota, how are you doing? Long time we met. I think 2009 or something. 2009 or
Maybe
2005, I think. Yeah.
I'm happy to listen to you, Dr. Sriram. I've been hearing about you for decades from SUB. So nice to hear wonderful talk from you. And your statement that the academic institutions don't talk anything about standards is 100% correct. They just don't give the importance of that, and it's so important that. But I find slowly the industry is realizing the importance, and they have now started participating in India. I'm happy to see that one.
Also, the thing is that in about 2000, around I think 2000 or so, I was asking the Indian counterparts, do they have? Is anyone working with STEP? That was the interoperability standard at the time, and the answer was no. Okay, so there was no effort at the national level to work in these things. So that's why I asked, what is India's national strategy for standards? Is there a one? Like Nitya Yogi or one of those organizations have to produce, like they have a strategy for artificial intelligence. Do they have a strategy for standards is the key question. And if not, you understand one thing, that we are, people talk about, again, here, this is my personal statement, not the statement of Nist, is that people talk about India being an economic horse, whatever is the, in the future. It's going to, economically, India is going to be in the leading economic leaders in the world. To be that, if you're not properly invested in standards, you're going to have trouble there. That strategy, they have to have the strategy.
No, the importance is understood, but the resources that are required, I find not enough resources are deployed. While the importance is understood, but the deployment of resources doesn't seem to be commensurate. Here, I'm not talking only money, but also the expertise, people. That is where the issue is. But I find more and more the importance is understood. Especially, I find that importance well understood by the IT industry and also by the government.
Yeah.
In that domain.
And
in areas like space and aeronautics, also the importance is well understood.
Dr. Sriram, thank you for your comments. I think in India, we glorify jugaad. Jugaad is exact opposite of standards, to my reading, and that is doing a lot of damage. Thank you.
I just want to make a remark, because I've been looking at standards development in different countries. I have documents after documents from China that standards education has been introduced at the high school level, at the bachelor's level, at the master's level, and at the PhD level of their curriculum. Because standards negotiation is an art. It's not just throwing technical things there. In fact, there are reports out, if any of you are interested, I can point them to you, that they have taken alternate standards to be. And in that standards milieu, Vietnam, Cambodia, Japan, all the East Asian countries are participating and India is not there. This is my assessment, personal assessment. And I think the way China has recognized the importance of standards and standards education is very critical if India is going to be a power. There is no other way to do it. And in fact, the US is struggling because many of the standards people came out after World War II, and many of them are retiring. So Nist has sponsored a program through which they are asking universities to have standards courses and giving funding to develop standards courses for undergraduate education. I just as a remark, I wanted to know.
Well
Yeah.
understood.
Also,
Well taken.
India has this thing, some like the UPI, which is the Unified Payment Interface, and that's doing a great job in terms of mobile payments and so on. So that's been pretty successful in terms of transferring money from one party to another party. Even like, for example, all vendors. I think I heard somewhere even the beggars may carry on their mobile phone saying that I have an UPI, send money to that. So that's a kind of progress that that has made. So I think there's potential. It's just a question of strategy. What is the strategy India has? Is a question that you need to ask.
Sudhir, you want to ask a final question and we close? We have 15 minutes about.
So essentially, if you look at standards, I think wherever there is a technology development lead or a technology advantage, then looking for standards in that domain could be an advantage for a country. So like, for example, if payments, there has been some progress in building a unified payment interface, then pushing for more standards around that and playing a more leadership role, that might make sense. Mm-hmm. But in cases where, suppose you're not the technology leader, then what kind of standards is a country going to develop? Can it come from the consumer or the application side? So is there a perspective where you can actually start building standards from a consumption or a consumer side of it?
Yeah. So actually, Sub, I think has been thinking on it for some time, but I'll give you my 2 bits here. So there are 2 things. As I said, there's a slide. There is the product providers, then you have the consumers, and then you have the standards test the test methods and conformity kind of things. So this ecosystem, there are all these players who will be playing different roles. Okay, and for example, in India, if India is actually an IT providers too. There's a lot of IT providers that are coming out from the Indian system, and then there are also consumers, okay, of these IT products. I'm only talking about IT, but there are other kinds of products. You have the mechanical products also, which are coming out of the place. But what you're saying is that in some of those things, India is not the leaders in the things. So how should we enforce standards? And that's where the consumers come into picture, along with this third party, not only third party, the government organization or whatever it is, which is doing the testing labs. India probably has some testing labs and those kinds of things. They're going to make sure the consumers are protected against these external forces, whether international or national.
If I may just make a remark, if you look at the way China has developed its standards structure, is coming from the consumer side a lot. So, for example, they already developed 3G standards while the Americans were developing 3G standards because they knew their customers can be captured having a huge market, in which case American companies have to conform to Chinese standards in order to provide. So, given the size of the market in India, for many things, consumer side can drive. For example, I would argue that UPI is a consumer side standard which came out of the needs of the consumer being satisfied. So I believe that there are a lot of spaces in which consumer standards can play a very important role. In fact, even in roads, in the way roads are built, it's a consumer standard, safety standard, right? And even if we build those things with alternate materials and alternate ways of doing things, there is a huge potential which is left open. In fact, if we go in that direction, we will have sustainability and other issues can be brought in developing new set of standards which are not available in the developed countries today. Okay? It's a question of thinking about how do you develop a national strategy which gives you a niche in the international world. That is why Ram's point that we have to have in India a national standard strategy in the context of the world we are operating, global world we are operating in, and the strengths we have, and how we can define the future standards. We cannot always be tagging on to the previous technology as the only solution forward. Okay. This is my personal remark on that. Yeah.
And so there's also
Very
the
valid, very important point.
and the notion of participating in global standards are very important, because
Yes.
the world, it's a global world. We're not talking about any specific, because this is for the good of the world, not good of a particular individual we are talking here. Okay.
Yeah.
Because this kind of serves two purposes: one, your own internal economy, and also for the good of the, the world economy. Because if the world economy is good, everyone, the local economies are also good.
Anyway, if there are no more comments, with that, we have gone 20 minutes longer. I think it is a very important topic that we wanted to lay out. And thanks, Ram, for doing this. It's really, we may follow up with other standards talks. Maybe I'll give one at some point, because I used to teach a course on standards. So,
But, a very, very fascinating talk. Thank you.
Thank you all. Have a good,
It's a pleasure meeting you
good
all.
evening, good day, everything. Bye.
Okay.